All right, 4 is actually a really big section. So I have decided to kind of think of it in two parts. So the first part is the transformations, and then the second part is the what I've decided to call, I think, properties of functions. So the second half of 4 is about symmetry and monotonicity. And I'm gonna, explain symmetry or monotonicity as a word here in a little bit. But first, let's focus on symmetry. Symmetry is exactly what you think it is. Symmetry. So your face has symmetry down the middle. Circles have symmetry, right? So this circle has symmetry down the middle, or across, actually any angle, because they're highly symmetric. This piece of paper has symmetry both this way and this way, because if you fold it, then it ends up on top of itself. So either way you fold it. So that's what we're looking at for functions. So I can either have symmetry with respect to the x-axis, the y-axis, or the origin. So I want to imagine putting a mirror on each of these axes to determine whether or not they have symmetry. For x-axis symmetry, I want to imagine, suppose this is what my function looks like up in the first quadrant. Then I want to imagine if I flip it over the x-axis, then it would be down here, right? Something like this. So up in the first quadrant live the points x, y. So if x, y is on the graph, so is what? Well, x's on here would still be positive, but the y's would be negative. So is x negative y. All right, y-axis symmetry. So I'm focusing on first quadrant because that's where everything's positive and kind of easy. For my y-axis, suppose this is my function in the first quadrant, then if I were going to reflect over the y-axis, be something over here. So these points are x, y. So if x, y is on the graph, so is, well, over on the other side, I still have positive y, but now my x's are negative. So is negative xy. All right, the last one is origin, which is maybe the weirdest. I can kind of think of origin as, how do I want to think of origin? Origin is like doing reflection across the x and then the y-axis. So if I reflect across the x-axis, I'm down here in quadrant 4, and then across the y, I'm back in quadrant 3. So I would get something like this. So if xy is on the graph, so up here, so is negative x, negative y. Okay, of the 3 types of symmetry, the most important is going to be y and origin, because if you have x-axis symmetry, you don't pass a vertical line test, and so you're not a function. So these guys aren't functions. This class is going to be interested in functions. So this comes up in the symmetry test, but in terms of actually caring about for the rest of the semester or in other classes, this thing doesn't really come up very often. All right, so these pictures that I've sketched tell us what our test should be, right? If you're on the graph, then you make the equation true. Okay. Sorry, the camera does a mirror, so moving left on the camera actually is moving right in real life. Okay, so x-axis. My x-axis says, symmetry, says that xy is on the graph, so is x minus y, meaning y and negative y are solutions, give me solutions to the equation. So I'm going to replace y by negative y. That's going to be my test for the x-axis. If I end up with something true, then I have that symmetry. My y-axis symmetry, so if xy is on the graph, so is negative xy. So that means for my test, I want to replace x by negative x. So then for origin, I'm going to replace both. All right, so let's look at what these look like, these tests in practice. Okay, so test the following for any symmetry. We're going to do 3 examples. This first one is x squared plus y equals 4. Now, I see an x squared, so that indicates to me that this is probably a parabola. If you rearrange this, you get y is negative x squared plus 4. That's a parabola that opens down and has been shifted up 4, right? So just based on a quick sketch, this should have y-axis symmetry, shouldn't have x-axis, and it shouldn't have origin symmetry. So that's what we expect to see from our test. X-axis test is we are going to, so x-axis means we go from positive to negative y's. We're going to replace y with negative y. If we end up with the same equation, then it's true and it has symmetry. So x squared plus negative y equals 4. That's x squared minus y equals 4. This is a fail because it is not the equation I started with, the prompt. Y-axis, I'm looking for replacing x with negative x. And if I end up with x squared plus y equals 4, then it's a pass. So negative x squared plus y equals 4. Well, negative x quantity squared is just x squared because squaring gets rid of negatives. So this is a pass. So I do have y-axis symmetry, which is what we saw in our sketch, or sketch the graph. Origin, I'm going to replace both. Now, since I've already done x and y-axis, I kind of know what's going to happen with my origin, right? I would need, so my negative x is going to go away, but my negative y won't. So this origin should fail. And again, based on the picture, that's what we'd want to see. So negative x squared plus negative y equals 4. That gives me x squared minus y equals 4, which is again a fail because it is not the same equation I started with up here. All right, so this one has only y-axis symmetry. Only y-axis symmetry. Okay, B. So this is y equals minus 3x plus 1. Off to the side, what is this thing? This is a line with intercept 0, 1 and a negative slope. So something like this. This shouldn't have any symmetry. It certainly doesn't have x or y axis symmetry. And it also shouldn't have any origin symmetry because it doesn't even go through the origin. So y-axis, x-axis, and origin should all fail. So for my x-axis symmetry, remember so remember for the x-axis, I'm going from positive to negative y's. So that's why my test is replacing y with negative y. All right, so I do my replacement, and if you want, multiply both sides by y, All right, so this line has positive slope and an intercept of -1. So this is a fail. Do not have x-axis symmetry. Y-axis. Okay, so the replacement for this, if I'm doing y-axis, I'm going to go from positive x's to negative x's because that's how my y-axis splits. So I'm going to replace x with negative x and see if I end up with the same thing. So this is y equals -3 times negative x plus 1, or y is 3x plus 1. So this is a line with positive 3 slope and intercept 0, 1, which is not my original equation. So this is also a fail. So I do not have y-axis symmetry. All right, origin. So now I'm going to replace x and y. Now sometimes if x and y fail in the quote-unquote right way, then when you get down to origin and you replace both of them, then you can get those negatives to cancel and end up with a true equation, and then you have origin symmetry. Probably not going to happen in this case. Again, we have our picture. No indication that there's origin symmetry. Yeah, no indication that there's origin symmetry. So let's go ahead and try this one. I mean, maybe, but, you know, probably not. All right, so negative y is -3 times negative x plus 1. So you get negative y is 3x plus 1, or y is -3x minus 1. So no origin symmetry. It's close, except I've got this -1 here. So I needed a +1 in order to have a true statement. So this is another fail. So this one is no symmetries. All right, one more. X squared plus y squared equals 4. So this is a circle. This is a circle centered at the origin. So h and k are 0. And has radius 2 because the r squared is 4. So this thing should have y-axis and x-axis and origin symmetry. Should have all of them. So my replacement for x, I'm going to go from positive y's, flip over to negative y's. So that's my test. So x squared plus negative y squared equals 4. X squared plus y squared equals 4. Remember, squaring gets rid of negatives. So this one is a pass. So it has x-axis symmetry based on our test. Y-axis, I'm going to go from positive x's, flip over the y-axis to negative x's. So that's my test. So negative x quantity squared plus y squared equals 4. Something squared when negative becomes positive, so I get x squared plus y squared equals 4. So another pass. So I do have y-axis symmetry, which we can see from our picture. Now both of these passed in such a way that I should have my origin symmetry. And if you have both x and y-axis symmetry, then you're going to have origin symmetry, because origin symmetry is just an x followed by y-axis reflection. All right, so negative x squared plus negative y squared equals 4, which means x squared plus y squared equals 4, which is a pass. So this has x, y-axis, and origin symmetry. All right. Now, in terms of importance level, I don't think that symmetry tests are that important, honestly. What's more important is what's covered after this, which is what's called even and odd functions. So with the symmetry, I would be able to like determine what symmetries a graph has. Like if I give you a picture, you can tell me what symmetry is there. I'm not really interested so much in these tests.